Hi everyone, Mr. Weiser here. This video is going to focus on talking about coterminal angles in a unit circle, what they are, and how to identify them. Well, let's get started. You're likely here because you have to know how to memorize certain coordinates and angles in a unit circle. This video is going to specifically talk about how to find where in a unit circle a specific angle is, or a coterminal angle, which we'll learn what that means. So a coterminal angle, well, simply put, an angle in a unit circle is going to always start at the x-axis. That's going to be our initial side. So the terminal side is where the angle ends. So when you see this theta symbol, that represents the angle in the unit circle. And to have a coterminal angle, we would want to have an additional angle with that angle that meets at the same spot. So you're going to notice that in this diagram, you're going to have an angle that opens up in the negative direction, clockwise, but it ends up in the same spot on the unit circle. So you notice that 240 degrees and the negative 120 degrees are going to end up right here at your terminal side. And those are going to be considered coterminal. To better understand what that looks like, let me give you a visual here on Desmos. All right, here's a graph of the unit circle. And you'll notice that I have two angles marked over here, theta 1 and theta 2, both starting at 0 degrees. Now, if I move one angle, let's say 60 degrees, then its terminal side is going to be this red line right here. The initial side is the black line. If I move the other angle, theta 2, in a negative direction, you'll see that eventually I can get it to match up and overlap the 60 degrees. Notice that these 2 degrees are ending on the same spot. They are fully 360 degrees apart. So those two angles would be considered coterminal. And I could keep going in another 360 degrees and end up in the same spot again. And that's going to give me at, it's going to be 660 degrees. Those are both going to be still on the same spot in the unit circle. And I can go in the positive direction and go past 60 degrees. So if I go to 60 degrees and I keep going another 360 degrees, I'll still end up in the same spot. And 60 plus 360, well, that's going to give you 420. And those two angles would be considered coterminal. So that's the definition of what it means. Now let's look into some examples. In these examples, we're going to want to find where the quadrant or x or y axis, a terminal side of an angle, ends up at. Now, you don't have to have all the coordinates and angles memorized in a unit circle to be able to answer these questions. You just have to know the basics where it is. So you're likely in a class that's going to require you to memorize these angles and coordinates. But let me kind of talk to you about how to identify them just with some basic understanding of quadrants. So first, with quadrants, they're always going to be labeled the same way. Quadrant 1 is going to be here on the top right. Quadrant 2 is going to be over here top left. 3 down here, and 4, and it keeps going. So they're always going to go in a counterclockwise direction. And then as far as the angles go, you should know at least the 90-degree angles, 180, 270, and 360, which is also 0 degrees. All right, if you know those two base angles, then you can pretty much figure out where any angle is, because it's going to lie between them. So for example, 210, well, where would that lie? Well, 210 is going to be between 180 and 270. So it's going to be right here. And this isn't asking for a specific coordinate. You could get the coordinate. It's right here, negative square root of 3 over 2, negative 1/2. But it just wants to know what quadrant. So that quadrant's going to be quadrant 3. So the rest of the examples on example 1 are going to kind of fit this category, but some may be in radians. How about example 2? We don't have a 2 pi over 5 radian in our unit circle. The unit circle that's going to be printed out for you, at least to work with in your notes, is only going to have specific coordinates and angles. It doesn't have everything. So 2 pi over 5 doesn't fit our nice little box of what's in this printed out version. So we're going to have to figure out what that degree is, and so we can identify where in the quadrant it is. So I'm going to take this off for a minute. It's not really going to be super helpful. We have to remember how to convert a radian to a degree. This is a radian, so we have to get it in degree. So if you don't remember how to do that, here's a little tutorial. If you do, convert it to degrees, and then we can figure out the quadrant. So 2 pi over 5, to convert to a degree, you have to multiply this by 180 divided by pi. You can use your calculator if you're allowed, but I'm going to do this without a calculator. These pi's would cancel out, and you're going to have 2 times 180 divided by 5. So 200 times 2 times 180 is going to be 360. 360 divided by 5 5 goes into 36, 36 7 times. So 7, let me do a little long division here. 60, 35, 10, so 72. So that's going to be 72 degrees. We don't have 72 on our unit circle, but we can still figure out the quadrant. We know that 72 is going to be between 60 and 90. So it's going to be in quadrant 1. So quadrant 1 will be your answer here. 72 is going to lie right somewhere in this general direction. And that's equivalent to 2 pi over 5 radians. So quadrant, I may have said quadrant 2, but that's actually quadrant. All right, a couple more examples here. I'm going to have you try them. Take a moment to try this one, and you can unpause it after I go over it. 160 degrees is between 90 and 180. So if you know where those two numbers are, we know that's going to be in quadrant 2. That's all you got to do on that one. Next question. In what quadrant does the terminal side of the angle lie when it's pi over 3? That's a radian. See if you can figure out where that is. Pause the video and you can check after you unpause it. So I'm going to do this without converting to degrees so you can see, just not how awful this is to actually do. So you do have to know that in terms of radians, that's 0. This is pi, which means this is going to be 1/2 of pi, which you can say pi over 2. This is going to be 1.5 pi's, so 3 pi over 2, and 2 pi. Now, where is pi divided by 3 going to locate? Well, pi divided by 3 is actually a smaller number than pi over 2. 1/3 of pi, if you think about breaking up where pi is, if you break it into thirds, there's 1/3 here, 2/3 here. So 1/3 of pi is going to be here, pi over 3. That's actually 60 degrees. Well, again, that's going to be in quadrant 1. You can verify that by converting it to a degree and understanding where that lies. And you can look at your unit circle if you need to check, but see where pi over 3 lies in quadrant 1. And that's how you identify it. All right, let's look at the next example. In this example, we want to find a measure of an angle between 0 and 360 that would fall on the unit circle that would be coterminal with the given angle. Now, coterminal angles are going to be increments of 1 full rotation, or 360 degrees. So what I'm going to do is just look at my 740 and realize that's too high. So the first thing I need to do to get the number that's positive is I need to subtract 360 and see where I lie. So if you subtract 360, you're going to get, how much is that? You'll get 380, which is too big. So we have to keep going to get down into 360. So just subtract until you get a number between 0 and 360. So let's do that again. So if you subtract 360 from there, you're going to get 20 degrees. And 20 is between 0 and 360. So we have found our angle between 0 and 360 that is considered to be coterminal with the given angle. As you can see from our interactive Desmos graph, that these two angles do lie up on the same spot on the unit circle. So to verify our answer. All right, we're going to backtrack to part A. Apparently I did part B first. So we're going to start with a negative degree this time, and we want to see if we can find, again, a coterminal angle between 0 and 360. So in this case here, since we're too small, we're going to have to add 360 to keep going. Now, if I add 360 one time, I know that's going to be too small, so I'll have to keep going. So if I start with negative 960 and just add 360, I'm going to get negative 600. And I'm just going to keep using my calculator until I get a number that works. 120 is going to be my landing spot here. So we'll just add 360 1, 2, 3 times to get 120 degrees. And once you have gotten your number between 0 and 360, you've answered the question. Now we're going to want to do this with radians as well. Now there's a couple approaches with this. One approach is you could actually get the radians converted to a degree and use it just adding 360 and subtracting 360. The benefit of doing that is it's a little bit easier to kind of comprehend. The drawback is it's going to take longer. The other way to do it is you can you can think about 360 degrees as 2 pi radians. So instead of adding or subtract 360, you could add or subtract 2 pi. And then we can leave it in terms of pi because they want it to be in radians here. So I'm going to go both approaches, and you can pick which one is going to work best for you. So if you're doing negative 2 pi over 3, we know that's going to be a negative, so we're going to want to add 2 pi to that. But these don't have common denominators. So when you're adding fractions, you have to get common denominators. So one thing I'm going to do is I'm going to make that. So notice that I don't have a 3 here. So I'll have to put a 3 there and multiply the numerator by 3 to make that equivalent. And that's going to give me 6 pi on top. So then I can now add my numerators together. So I'll have negative 2 pi plus 6 pi, and those are both going to be over 3. So if I combine these two, that's going to add to positive 4 pi over 3. Does that fall between 0 and 2 pi? Well, it does, because 4 divided by 3 is a number that is going to be between 0 and 2. So 4 pi over 3 will be your answer. Now let's do the degree approach. If that helps you do it with the 360, then that's fine. So let me clear this off. Now, as far as doing it with degrees, you're going to have to convert negative 2 pi over 3 to degrees. So we're going to have to do negative 2 pi over 3 multiplied by 180 over pi. We're going to have to cancel out the pi's. Negative 2 times 180 is negative 360 divided by 3. And I know 3 goes into 36 12 times, so it's going to be negative 120. So now I'm going to take my negative 120 since it's negative, and I'm going to add 360 degrees. And that's going to put me at a number between 0 and 360. That's actually going to be 240 degrees. But we can't leave it like that because we were talking about radians. So my step after that would have to be converting it back to radians to get my final answer. So if I take 240 to convert to radians, I'm going to divide the 180, reduce that fraction, and multiply it by pi on top. So 240 over 180, I can reduce that. That's 24 over 18. Both of those are divisible by 6. So if I divide both by 6, 24 divided by 6 is 4. 18 divided by 6 is 3. But we do have to put the pi back in. So it's going to be 4 pi over 3 radians. That's coterminal with negative 2 pi over 3. A little bit less, more time consuming to do it that way. But, whatever works for you is ultimately the best thing. You should probably try this one on your own. So pause the video, and then you can unpause it and try it and check the answer. All right, here we go. So I have 7 pi over 2. That's going to be too big. If you look at 7 pi over 2, we know that 7 over 2 is going to be greater than 2. So it's not between 0 and 2 pi, meaning that we're going to have to subtract since it's too big. So 7 pi over 2 minus 2 pi is going to be, well, once again, I have to have common denominators. So I'm going to put times 2 times 2, and that's going to give me 4 pi on there. So 7 pi over 2 minus 4 pi over 2. Well, 7 minus 4 is 3, so that's going to be 3 pi over 2. 3 pi over 2. If you want to convert it to degrees to try it, you can. 3 pi over 2, 3 over 2 is a number between 0 and 2. It's 1.5, so that will fall in the unit circle, and they are coterminal. And that's your answer. That concludes this video. The next video, we'll be talking more about specific rotations around a unit circle and how to get those coordinates in angles. Thanks for watching.